In this video, we're going to have a look at how we can graph sine and cosine functions that have undergone both vertical and horizontal translations, as well as dilations of the period and the amplitude. Now, in this case, we're going to graph y equals 3 sine 2, or 2 times t minus pi over 4 plus 2 over a range or over a domain of pi on 4 and 5 pi on 4. So notice the particular form in this case. In the previous example, we had y equals a for amplitude, sine 2 for the n, I should say n, and that was in parentheses, and then it was t minus the epsilon here. And this was if we were doing horizontal translations, but now we're going to introduce another term, b. So the b here is for the vertical translations. So consider if we tried to graph this function here, so y equals 3 sine 2 times t minus pi over 4 plus 2, and I'll add parentheses just in there. What we're going to find is that a is going to be 3, so amplitude dilation of 3, period dilation of a factor of 2. We're going to get an epsilon, so an epsilon here. We're going to get an epsilon of negative pi over 4, and then we're going to get a b, so this vertical translation of 2. And notice, because it's positive 2, we're going to go in the upwards direction, so we're going to lift our function positively in the y direction. If it was negative, we'd push it downwards in the negative y direction. Now, to start off this video, I'm thinking we'll graph this particular one using Desmos. So we've got an a value of 3, and we had an n value of 2, I believe. We had a shift, or a vertical shift, of negative pi divided by 4. And then we had this b value here. So notice what we've got here is the translation of our graph. And if I do it over one cycle, I should say it was a sine graph, not a cosine. So after one cycle, what we'll find is that this is what our graph looks like. It starts at point pi over 4 and it finishes at 0.5 pi over 4. Now watch what happens if we introduce this vertical scale, or this vertical translation factor of b. So at the moment it's at 0. If I go b positive, the graph is going to lift upwards. So if I lift it to 2, as seen in the question, the graph itself, it's going to have, at its start value, pi on 4, it's going to have a vertical position, or a y coordinate, of 2. And then at the end it's going to be 2 as well, but it will have a maximum of this b value plus the amplitude, which will be 5, so 3 times 5, and it will have a minimum of b, so I have b here, of 2, minus the negative value of the amplitude of 3, so negative 1. So using digital technologies, this is what would occur. Now, if I put it to negative, notice it can go below the x-axis. So now let's have a look at how we can do this manually. So consider we've got all of our factors over here. The way in which we're going to graph this is, firstly, I'm going to draw like an imaginary axis. So I'll put this one away for now. And what I'm going to do is I'm going to go grab my red pen, and I'll just jot down like a dotted line. And for now, we'll just pretend that this is our t-axis and use it as such. So there we go. And then my next step is I'm going to identify the start point. So my start point of this function is going to be my epsilon, which is negative pi over 4. Now, because this is negative pi over 4, it means I'm going to have a shift, a shift to the right. So rather than saying negative pi over 4, I'm going to say pi over 4. And this is going to be a sine function. So what I'm going to expect is that I'll have the general shape. My function looks something like this. So it's going to start at pi over 4 and it's going to finish somewhere over here. So the next question is, what's my period going to be? So calculating the period for this function, we're going to rewrite out the equation and we'll say y equals 3 sine 2t, and grabbing the value of n, so n equals 2, we can go period equals 2 pi over 2, thus we've got a period of pi. Now, working at this position here, it's going to be pi on 4 plus pi. So that's going to be 5 pi over 4. And then this midpoint here, this cutting point, it's going to be the midway between pi on 4 and 5 pi on 4, which is simply 3 pi on 4. Alright, excellent. Now the next step is, whereabouts is the x-axis, or where does this function cut my x-axis? And looking at this function, it would be a little bit ambiguous to figure out whereabouts it cuts it. So what we can do is we can highlight our maximum and minimum points first. We'll go, this is going to be this maximum. It's going to be somewhere, or it's going to be midway between pi on 4 and 3 pi on 4. So that will be 2 pi on 4. And it's going to have a maximum y value of b plus the amplitude, so 3 plus 2, so that's going to be 5, and it's going to have a minimum of 2 minus 3, so negative 1. So I'll put that in down here. So midway between here is 4 pi over 4, or simply just pi. Perfect. So notice that our x-axis is going to be somewhere down here. So what I can do is I'll grab this t-axis and I'll put it, say it's roughly about there. That looks pretty close. And then putting in our y-axis, we can simply draw it like this. So this would be 0 radians here, and up here this would be 5, and down here this would be negative 1. So in summary, to graph this particular function, what I did was, in comparison to the previous ones of just putting down a horizontal axis, firstly I dropped down just a dotted line to represent where the function is going to oscillate about. And then I figured out where all of the turning points would be. And only after then, figuring out where it would cut the axis, I just estimated and said that it's going to cut somewhere around here. And then I finished the question like in the previous examples. So this would be an example of how to sketch it manually. Of course, you could figure out all of the points. So say this cutting point here and this cutting point here using your calculator. But this would be a rough example of how to just sketch really fast